Introduction to motion. Motion is a characteristic of all living things. All living things can move on their own, like humans walk, birds fly, etc. Plants can move their different parts. Non-living things cannot move on their own. Some force must be applied to move them. For example, a boy applies a force to move a box. Let us now define motion. If the position of a body changes with time relative to any fixed point in its surroundings, then the body is said to be in motion. Rest means if the position of a body remains unchanged with respect to any fixed point in its surroundings. For example, a book lying on a table or any building. Rest and motion. When we are sitting in a moving car, did you observe any change in the motion inside the car? No. The position of the body in the car is at rest. Now look outside the car. You will find out that all objects are left behind in the opposite direction of the moving car. What do you think about this? When we look inside the car, you and our body are in same position. So we are in the rest position. But when we look outside the car, relative position of us and outside bodies are different. So they are in motion. Thus we can define as motion and rest. Rest and motion are relative. This means that the same object may be at rest with respect to one reference point and in motion with respect to another at the same time. Physical quantity. In physics, we deal with two kinds of quantities, such as scalar quantities and vector quantities. Scalar quantities. A physical quantity described by its magnitude or size only. Example, speed, time, distance, area, temperature, etc. Vector quantities. A physical quantity is described by both its magnitude or size and direction. Example, weight, force, displacement, velocity, etc. Scalar quantities are written only by the sign of the quantity. Example, distance s. Vector quantities are written by the sign for the quantity with an arrow at the top. Example, velocity v. Uniform and non-uniform motion. Observe the motion of a toy car. A toy car starts its journey from origin at time t is equal to 0. It travels 10 centimeters in the first second, another 10 centimeters in the next second, and another 10 centimeters in the third second, and so on. The toy car covers equal distance in equal intervals of time. That is, in every 1 second, the car is covering 10 centimeters. This kind of motion is called as uniform motion. So the uniform motion is defined as equal distance traveled by objects in equal time interval. Now observe the motion of the toy car. The toy car starts its journey from origin at time t is equal to 0. It travels 10 centimeters in first second, 5 centimeters in next second, and then 10 centimeters in the third second, and 20 centimeters in the fourth second, and so on. The toy car is covering unequal distances in equal intervals of time. This kind of motion is called as non-uniform motion. In our day-to-day life, we come across non-uniform motions. Distance and displacement. Motion can be described by two quantities: distance, displacement. Distance is the total length of the path covered. It is a scalar quantity. Displacement is the shortest distance between the initial position and the final position. It is a vector quantity. Let us understand the difference between the distance. An athlete is running around a circular track of radius r. He starts from point A and stops at the same point. Let us calculate the distance and displacement. Distance covered is equal to circumference of the track is equal to 2 pi r. What is the displacement when the athlete comes back to the same point from where it started? Since the initial position and the final position of the athlete are same, so the displacement is equal to 0. Let us suppose that the athlete now starts from point A and stops at a diametrically opposite point B. Distance in this case is equal to pi r. Displacement is equal to the shortest distance between the initial point A and final point B is equal to 2r. Let us take another example. A car starts its journey from point A, moves 4 meters and reaches point B. Then it takes a left turn and travels 10 meters and reaches the point C. Again it takes a left turn and travels 4 meters and stops at point D. So the distance travelled is equal to AB plus BC plus CD is equal to 4 meters plus 10 meters plus 4 meters is equal to 18 meters. Displacement is equal to shortest distance between the initial point A and the final point D is equal to 10 meters. Speed and velocity. Look at the moving of a car. How fast or slow cars are moving. We need to calculate the speed. So speed is equal to distance travelled by cars divided by time taken. Speed of car red is equal to 90 km by 1.5 hour is equal to 60 km per hour. Speed of car blue is equal to 60 by 1.5 is equal to 40 km per hour. Thus we can say speed of red car is faster than blue car. Thus the speed is defined as the distance travelled by objects per unit time. It is a scalar quantity. SI unit of speed is meter per second, but speed is measured in kilometer per hour. Miles per hour is known as knots. When an object travels equal distances in equal intervals of time, the speed of the object is said to be uniform, as shown here by cars in motion. When an object travels unequal distances in equal intervals of time, the speed of the object is changing and is said to be non-uniform speed, as shown here by cars in motion. In the case of non-uniform speed, we describe the rate of motion in terms of its average speed. Average speed is equal to total distance travelled by the objects divided by total time taken. If we divide magnitude of displacement by time taken, we get average velocity of car as given in this section. Velocity is a vector quantity. That is why we indicate the direction initial to the final position even the car changes direction of motion. If we consider the displacement in short period of time, the magnitude of velocity is equal to the speed, but it shows the direction of objects. Thus velocity is defined as the displacement of the body per unit time. Velocity is equal to displacement by time. Velocity is represented by v. It is a vector quantity. The SI unit of velocity is meter per second. Other units of velocity are kilometer per hour and meter per minute. Velocity may be positive, negative or zero, but the speed is never negative. When a body is moving along a straight line covering equal distances in equal intervals, the velocity is said to be uniform. Observe the motion of this blue car. It is moving very fast, but suddenly its speed is decreasing. It is said to be non-uniform velocity. When a body covers unequal distances in equal intervals of time, or if the direction of motion of the body is changing, the velocity is said to be non-uniform. When the velocity of a body is changing at a uniform rate over a period of time, then average rate of the body for this period is the arithmetic mean of initial and final velocity. Acceleration. The rate of change of velocity is expressed by a quantity called as acceleration. So the non-uniform motion is an accelerated motion. Did you notice that the car stopped by producing a screeching sound? The car stopped because the driver applied the brakes. Let us study this in detail. Speedometer of a vehicle shows the instantaneous speed, which means the speed at that instant. Just observe the movement of the needle of the speedometer. It is showing that the speed of the car is changing with time. Sometimes speed of the vehicle remains the same, but its direction of motion changes. This change in speed or direction of a body in unit time is defined as acceleration. Acceleration can also be defined as the change in velocity per unit time. Acceleration is equal to change in velocity by time taken. A is equal to v minus u upon t, where a is the acceleration, U is the initial velocity, V is the final velocity, and t is the time taken. Acceleration is a vector quantity. Unit of acceleration is meter per second square. Acceleration can be positive, negative, or zero. If the speed is increasing with time, the acceleration is positive. If the speed is decreasing with time, the acceleration is negative and is called retardation. If the speed is uniform or constant with time, acceleration is zero. When an object is thrown upward, initially it is moving at constant deceleration motion and then uniformly acceleration. Look at the car. It is moving with uniform motion and its speed does not change as the time passes. Therefore, it is defined as the change in velocity by equal amounts in equal intervals of time. Or, the acceleration is said to be constant or uniform. In non-uniform motion, the acceleration varies with respect to time. Therefore, it is defined as the change in velocity by unequal amounts in equal intervals of time. Or, the acceleration is said to be variable or non-uniform. Distance time graphs. The distance time graphs represent the change in position with time. In this graph, time is taken on x-axis and distance is taken on y-axis. When the object is moving with uniform velocity, the given table represents the distance covered by a car at different instants of time. Let us learn how to plot the distance time graph for this car. Draw two straight lines, one in the horizontal direction and the other in the vertical direction. The horizontal line is called the x-axis and the vertical line is called the y-axis. The point of intersection of the axis is called as origin. Plot the time on x-axis and distance covered on y-axis and choose a proper scale so that the values can be properly marked. According to the values of time and distance, mark the points on the graph. Join the plotted points to get the graph. Consider any two points A and B on this straight line. Drop a perpendicular from these points on the x-axis and y-axis and construct a right-angled triangle ABC. Find the slope of the straight line graph. This slope gives the speed of the moving car. So from the distance time graph, we can calculate the speed of the body, which is equal to 2 meters per second. Case 2. When the object is at rest. From the given values in the table, we can infer that an object is stationary at a distance of 10 meters from the origin. The position of the object does not change with time. So at all instants of time, the distance of the object remains the same, that is 10 meters. When we plot distances at different instants of time and join all the points, we obtain a straight line parallel to the time axis. So the distance time graph for an object at rest is a straight line parallel to time axis. Case 3. When the body is in non-uniform motion or accelerated motion. Let us consider a car in non-uniform motion. Let the given table represents the distance covered by it at different instants of time. Let us plot these points. Let us join the points to get the required graph. Notice that the distance time graph for a non-uniform motion is a curved line. Draw a tangent to the curve at any point. Slope of the tangent to the curve at a point gives the speed of the object at that point. Velocity time graph. The velocity time graph represents the change in velocity with time. In this graph, time is taken on x-axis and velocity is taken on y-axis. Case 1. When the body is moving with a uniform acceleration. The given table represents the velocity of a car at different instants of time. Let us learn how to plot the velocity time graph for this car. Draw two straight lines, one in the horizontal direction and the other in the vertical direction. The horizontal line is called the x-axis and the vertical line is called the y-axis. The point of intersection of the axis is called as origin. Plot the time on x-axis and velocity on y-axis and choose a proper scale so that the values can be properly marked. According to the values of time and velocity, mark the points on the graph. Join the plotted points to get the graph. Consider any 2 points A and B on the straight line. Drop a perpendicular from these points on the x-axis and y-axis and construct a right-angled triangle ABC. Find the slope of the straight line graph. This slope gives the acceleration of the moving car. That is, acceleration is equal to BC by AC, which is equal to 10 meter per second square. Velocity time graph can be used to calculate the distance traveled in a particular time interval. Let us see how to calculate the distance traveled. Mark the points D and E on the graph. Distance traveled is given by the area enclosed between the plotted graph and the time axis. Let us calculate the distance traveled between 2 seconds and 4 seconds. It is equal to the area of triangle plus area of rectangle. By solving, we get the distance traveled between 2 seconds to 4 seconds equal to 40 meter. Case 2. When the object is moving with uniform velocity. Observe the data in the given table. Velocity at all instants of time is same. This kind of motion of uniform motion and the velocity is said to be uniform velocity. According to the values of time and velocity, mark the points on the graph. Join the plotted points to get the graph. Consider any 2 points A and B on the straight line. Drop perpendicular AC and BD from these points on the x-axis. Let us calculate the acceleration. Acceleration is equal to change in velocity per time taken is equal to 20 minus 20 by 5 minus 1 is equal to 0. So acceleration for uniform motion is equal to 0. Let us now calculate the distance traveled between 1 second to 5 seconds. Distance traveled between 1 second to 5 seconds is equal to area of rectangle ABDC is equal to AB into BD is equal to 5 minus 1 into 20 is equal to 80 meter. Case 3. When a body is moving with non-uniform motion or accelerated motion, then the graph will be a curve which is increasing and decreasing. Derivation of equations of motion. There are 3 equations of motion. V is equal to U plus AT. S is equal to UT plus half AT square. V square minus U square is equal to 2AS, where U is the initial velocity at time t is equal to 0, V is the final velocity after time t, and A is the uniform acceleration, and S is the distance traveled in time t. Derivation of first equation of motion. V is equal to U plus AT. Taking the time on x-axis and velocity on y-axis, let us draw the graph of an object moving along a straight line with uniform acceleration A. The required graph will be a straight line inclined to y-axis. The initial velocity is U at time t is equal to 0 and the final velocity is V at time t. Draw AD perpendicular to BC and BE perpendicular to OY. We know that acceleration is equal to slope of velocity time graph. So A is equal to BD by AD. Let it be equation 1. But BD is equal to BC minus CD is equal to BC minus OA. Putting the value of BC as V and OA as U, we get BD is equal to V minus U and AD is equal to OC is equal to T. Putting the above values in equation 1, we get A is equal to V minus U divided by T. So after rearranging, we get V is equal to U plus AT. Derivation of equation for position-time relation. S is equal to UT plus AT square divided by 2. Let S be the distance travelled by the body in time t. Distance travelled is equal to area enclosed by velocity time graph, which in this case is equal to the area of figure OABC. Therefore, S is equal to area of triangle ADB plus area of rectangle ADCO. Area of triangle ABD is equal to base into height upon 2 is equal to AD into BD by 2. In the graph, AD is equal to OC and BD is equal to BC minus CD. Area of triangle ABD is equal to half into OC into BC minus CD. Area of rectangle ADCO is equal to length into breadth is equal to OA into AD. Adding these two areas, we get S is equal to AD into BD by 2 plus OA into AD is equal to half into OC into BC minus CD plus OA into AD is equal to half into OC into BC minus OA plus OA into AD. Putting the values in the above equation, we get S is equal to half into T into V minus U plus U into T. So S is equal to UT plus half into T into AT. Putting V minus U is equal to AT, we get S is equal to UT plus half AT square. Derivation of equation for position velocity relation. 2AS is equal to V square minus U square. Distance travelled S is equal to area of trapezium OABC is equal to sum of parallel sides divided by 2 into height is equal to OA plus CB by 2 into OC is equal to U plus V by 2 into T. We know that V is equal to U plus AT. T is equal to V minus U by A. So S is equal to U plus V by 2 into V minus U by A is equal to V square minus U square by 2AS. So 2AS is equal to V square minus U square. Uniform circular motion. Circular motion means when an object is moving along a circular path. Example, motion of blades of an electric fan, Earth moving around the sun. Let us explain with help of an activity. Take a string and tie a stone at one of its ends. Hold its second end in your hand and whirl so that the stone performs a circular motion. Speed of the stone should remain the same throughout the motion. So the motion of the stone is uniform circular motion. To know the direction of velocity of stone at any point, release the stone at that point and observe the direction in which it goes. If this activity is carried out 4 or 5 times at different points, you will observe that the stone travelled in different directions every time. Direction of stone is a straight line and is along the tangent to the point of release. Thus, the direction of velocity keeps changing every moment in uniform circular motion. In uniform circular motion, speed of the body remains constant, but the direction of motion is changing continuously. Therefore, we can say in a uniform motion, velocity is changing continuously. Hence, it is an accelerated motion. Consider an athlete moving along a circular track of radius r. Consider any point A on the track. Direction of velocity at any point A is along the tangent to the circle at point A. Time taken by athlete to cover one round is equal to T. Distance covered in one round is equal to circumference is equal to 2 pi r. So speed of athlete V is equal to distance by time, that is 2 pi r by T.